We are going to look at work problems and how we can use rational equations to solve work problems. So let's begin with warming up and let's be thinking about these types of questions. If Micah takes 2 hours to mow the church lawn, how much of the job does he have done after 1 hour? Well, if it takes him 2 hours to complete the entire job, then after 1 hour, he's only halfway done. So we would say he only has half of the job done. So let's look at Joe. Joe takes 3 hours to mow the church lawn. So how much of the job will he have done after 1 hour? Well, since it takes him 3 hours to do the entire lawn, after 1 hour, you'd only have 1/3 of the job done. Now let's generalize it. Let's say it takes Bob X amount of hours. Then how much does he have after 1 hour? Well, he'll have 1/x of the work done. So in all of these problems, we would say that the time for one job would be X. And the amount done in 1 hour would be 1/x. So here is another type of question. How much of a job can Jill get done in 1 hour if the whole job takes 5 hours? So if the whole job takes 5 hours and she's only done 1 hour worth of work, then she can only get 1/5 of the job done. Now, what if it's a job that takes 2.5 hours? Well, since she's only doing 1 hour's worth of work, it would be 1/2.5, or 1 divided by 2.5, or 1 divided by 5/2. So if it was 1 divided by 5/2, and division is the same as multiplying by the reciprocal, that would be 1 divided by 2/5, or 2/5, which means she would have 2/5 of the job done after 2.5 hours, or in 1 hour, if an entire job took her 2.5 hours to do. All right, so here is the next one, and this is a little bit more tricky because the entire job takes 15 minutes. So how much does she get done in 1 hour? So we have to make sure that our units are in hours. So 15 minutes is 1/4 of an hour. So if it only takes her 1/4 of an hour to finish a job, and she was working for the entire hour, that means that she can actually get 4 jobs done in 1 hour if a whole job is finished in 15 minutes. All right, next question. So Jill can get half the job done in 1 hour, and Jack can get 1/4 of the job done in 1 hour. So how much can they get done together in 1 hour? So how much together do they get done? So for this one, since they're working at the same time in the same hour, we would just add what they're getting done. So we would add Jill's 1/2 and we would add Jack's 1/4, and then that would tell us how much they get done together. So we would change that 1/2 to 2/4, and we would add it to the 1/4, which means that they would get 3/4 of the job if they work together. Okay, so if you know how much each person can get done in 1 hour, then just add them up to see how much total they can get done in 1 hour. So questions like that are your friend because that's super simple. You just add the work that they individually do and you put them together, and that's how much they get done together. So for example, let's say Susan gets 2/7 of the job and Joyce can do 3/7 of the job, both in 1 hour. You would add those together and that would be 4/7. So they would get 4/7 of the job done in 1 hour. Let's say Susan can do 3/5 and Joyce can do 2/3. So for this one, to add them together, we would first have to get a common denominator. So that would be 15. So to make that 5 and 15, I would have to multiply by 3, which would make that a 9 in the numerator. And then to make that 3 a 15, I had to multiply by 5. And 2 times 5 is 10. So that's 10 over 15. So together, they would get 19 over 15 done, or we could also say 1 4/15 of the job done. So one whole job and then 4/15 of another job. So working together has its benefits. You get more of the work done. So in this one, Susan can get 2/5 of the job done in 1 hour, and Joyce can get 2/10 of the job done in 1 hour. So there is a couple ways you can think of this. If you think, oh, 2/10 is the same as 1/5, which means that they get 3/5 done together. You could have done that using mental math, or you could have done the old standby and just make the denominators the same. So to make that 5 a 10, I would multiply by 2, which means I would multiply that 2 by 2, and that 2/5 turns into 4 over 10. 4 over 10 plus 2 over 10 is 6 over 10, and then 6 over 10 reduces to 3 over 5 when you divide both the numerator and the denominator by 2. So usually in work problems, we're going to be given the amount of time it takes for one job. And then we usually want to know how long it will take to get the job done. So we're going to let the time for one job be X, which means that the amount done in 1 hour would be 1 over X. So remember the problems that we looked at the beginning to help you remember that that's what we do. So the amount done in 1 hour would be represented by 1 over X. So when we set up our equations, that's what we're going to use for that part of the equation. The amount done in 1 hour is represented by 1 over X, where X is equal to time for one job. So an example, let's say we have the amount done in 1 hour is 6 over 10, which means that the time for one job would be 6 over 10, would be 1 divided by 6 over 10, which is the same as saying 1 times 10 over 6, which is 10 over 6, or reduce that, and that would be 1 4/6, which is 1 2/3, and 2/3 of an hour is going to be 40 minutes. So we get 1 hour and 40 minutes. All right, so let's do some examples. Let's say it takes Sally 2 hours to clean the house by herself, and it takes John 2 hours to clean the house. So how long would it take them to clean it together? Okay, so if Sally takes 2 hours to clean the house, then in 1 hour she has done half the job. And then if John takes 2 hours to clean the house, then that means it's taking him half the job. And so the amount done in 1 hour is 1/2 for Sally and 1/2 for John. So that means together in 1 hour they will have completed one job. So that means you can get one job done in 1 hour. So you can create a table to represent work problems. So you're always going to put horizontally, it's going to be the titles, right? So you'll have person, you're going to have a column for the time for one job, and then you'll have a column for the amount done in 1 hour. So let's look at Sally. So Sally, it took her 2 hours for one job. That means that the amount done in 1 hour is going to be 1 over 2. Then for John, it took him 2 hours as well to do one job, which means that the amount done in 1 hour for him would be 1 over 2. So together, we don't know how long it took them together for one job, so we'll just represent that as an X. So remember, time for one job is always represented with an X, unless it tells you together they took this long for one job. So for this column, it's always, for the amount done in 1 hour is always going to be 1 over X. So it'll be 1 over 2 in this one. And then for John, it would also be 1 over 2. I'm getting the 2 from this. And that means together it would be 1 over X. So remember, when we solved this without the table, all we did was 1/2 plus 1/2, and that was equal to 1. So whenever you're solving work problems, once you have the table set up, all you have to do is add the first 2 rows and set it equal to the last row, and that's how you'll solve the work problems. So again, you're taking that third column and you're adding up the first 2 rows to get the third row. So for work problems, this is how you solve them. You make the chart, you fill in what you know, and then write the equation from the last column and solve for X. So let's do an example doing that. So Sam can do the yard work in 3 hours, and his dad can do the work in 2 hours. How long will it take them to do it together? So we have Sam and Dad, and we have them doing it together. So the first column, and that's the first column, is the person, right? So Sam, Dad, together. Now we look at the time it takes them to do one job. So remember, Sam can do the job in 3 hours, and Dad can do the job in 2 hours. And we want to know what's the time that they need to take together for one job. And then we'll look at our last column, which is the amount done in 1 hour, which is always going to be 1 divided by the time for one job. So it'll be 1 divided by 3 for Sam, 1 divided by 2 for Dad, and 1 divided by X together. And then to solve this work problem, we're going to take that third column. So we'll do 1/3 plus 1/2 equals 1 over X. So 1/3 plus 1/2 equals 1 over X. So we can kill our fraction by multiplying everything by 6x because that's the least common multiple of 3, 2, and x. So we end up with 2x plus 3x equals 6, which is 5x equals 6, which is 6 over 5, or 1 1/5 hours. All right, water pumps. This is another work problem. Let's say pump A can do the job in 5 hours, and then a second pump is added. And the job only took 2 hours when the second pump was added. So we don't know how long the second pump would have done by itself, but we know that when the pump A and pump B were working together, it only took them 2 hours. So our mission is to figure out, well, how long would it, if the second pump was working by itself, how long would it have taken to get the job done? So still use the same setup for our chart. So remember, the first column is you list them, and then you have one for them together. So here's pump A, here's pump B, the second pump, and then here are they together. And so remember, the second column is the time for one job. So remember, when A was going by itself, it took 5 hours. And then B got added, but we don't know how long B will be by itself. In fact, that's what we're trying to solve for, so that's where our X goes. And then we want to figure out, well, how long are they going to be together? We know how long they are together. They're together, it only takes them 2 hours. So now we fill in the third column. And remember, the third column is super easy. It's always 1 divided by whatever number is over here. So that will be 1/5. This will be 1 over X. And this will be 1 over 2. And then to solve the problem, we just add up the last column and set it equal to that bottom right box right there. So it'll be 1/5 plus 1x equal 1 over 5 plus 1 over x equals 1 over 2. So let's kill our fraction. Let's start with multiplying everything by 5. So we get 1 because we killed our fraction. We killed that 5 right there. So 1 plus 5 over x, because we had to multiply that 1 by 5, equals 5 over 2, because we had to multiply that 1 by 5. Now let's kill the next denominator, the x. So we're going to multiply everything by x. Multiply the 1 by x, multiply 5 over x by x, so that way it'll cancel, and then multiply 5 over 2 by x. So we end up with x plus 5 equals 5x over 2. Now we'll kill our last denominator, we'll kill that 2. So we're going to multiply everything by 2. So multiply this by 2, multiply the 5 by 2, and multiply 5x over 2 by 2, and then that will cancel that 2. So we'll end up with 2x plus 5 times 2 is 10 equals 5x. So a little algebra, we'll subtract 2x from both sides, and we get 10 equals to 3x, or x is 10 over 3, which is 3 1/3. So pump B would take 3 1/3 hours to do the job all by itself. Okay, next question. It takes Kevin 12 hours to get the materials ready for VBS. And then if Chris helps them and they work together, they can get it done in 3 hours. So the question is if Chris was doing the job by himself, like how long would it have taken Chris to do if Kevin wasn't helping? So let's set up our table. So we have Kevin, Chris, and then we have them working together. So the time for Kevin was 12. We don't know how long Chris would have taken, so that's x, but we know that together they got it done in 3 hours. So now we fill in our last column, and it's always going to be 1 divided by whatever number is in that second column. So it'll be 1 over 12, 1 over x, and then 1 over 3. And then to solve it, we just make an equation out of that last column. So it'll be 12 plus 1 over x equals 1 over 3. We'll kill our fraction. We'll start with multiplying everything by 12. So we get 1 plus 12 over x equals 12 over 3. Remember, 12 over 3 is the same as 4. So then we're going to kill this denominator, which is an x. So we'll multiply everything by x. We'll multiply 1 by x to get x. We'll multiply 12 over x by x to get 12. And then we'll multiply, remember 12 over 3 was 4, so we'll multiply 4 by x to get 4x. We'll subtract x from both sides, and now we have 12 equals 3x, which means x is equal to 4 hours, which means Chris, if he was working by himself, would have taken 4 hours to get VBS ready. Next question. Jerry can put a puzzle together in 5 hours, and Kathy can put it together in 7 hours. So, how long is it going to take them to do it together? All right, so we set up our table. In that first column, we have names. We have Jerry, Kathy, and then together. So the time for Jerry was 5, Kathy was 7, and together, we don't know, that's x. And then amount done in 1 hour is always going to be 1 divided by whatever number it took them for one job, right? So it'll be 1 over 5 for Jerry, 1 over 7 for Kathy, and then 1 over x together. So for this one, again, the same as all the other work problems, we are going to create a rational equation out of that third column. So it'll be 1/5 plus 1/7 equals 1 over x. Here we go, 1/5 plus 1/7 equals 1 over x. We will kill our fraction by beginning by multiplying everything by 5. So 1/5 times 5 is 1. 1/7 times 5 is 5 over 7. And 1 over x times 5 is 5 over x. Then we're going to kill our next denominator, which is the 7. So 1 times 7 is 7. 5/7 times 7 is 5. And then 5 over x times 7 is 35 over x. Now that we're here, we're going to kill our next denominator, which is the x. So we're going to multiply everything by x so that denominator can go away. So 7 times x is 7x. 5 times x is 5x. 35 over x is 35 over x times x is 35. So 7x plus 5x is 12x. 12x. Divide both sides by 12. So 35 divided by 12. If we round to the nearest tenth as we were directed, 35 divided by 12 would be 2.9. Okay, here is another problem. A factory says that it takes 5 hours to wrap 1,000 candy bars. To keep up with the demand, they need to get 1,000 bars wrapped every 3 hours. So if they buy a new machine, how fast does that machine have to be and able to get the job done by itself? The new machine by itself. So set up a table. So we have the current machine, the new machine, and then the machines working together. So the current machine, it takes 5 hours. The new machine, we don't know. We're trying to figure out. And then that means, and then together they have to get it done in 3 hours. Like that has to get done in 3 hours. So that's the second column. And once we have the second column, everything else is easy because this third column, the amount done in 1 hour, is always going to be 1 divided by whatever is over here in this column. So it'll be 1 over 5 for current. It'll be 1 over x for new. And then it will be 1 over 3 for together. So then we set up a rational equation with this third column. So it'll be 1/5 plus 1 over x equals 1 over 3. So we will begin with killing our fraction by multiplying everything by 5. So 1/5 times 5 is 1. 1 over x times 5 is 5 over x. And 1 over 3 times 5 is 5 over 3. Killing our next denominator, we're going to multiply everything by x. So 1 times x is x. 5 over x times x is 5. And then 5 over 3 times x is 5x over 3. Now we will kill the next denominator, which is that 3. So x times 3 is 3x. 5 times 3 is 15. 5x divided by 3 times 3 is 5x. We will subtract 3x from both sides, and we get 15x is equal to 2x. Divide both sides by 2, and you get 7.5 hours. And that's rounded to the nearest tenth as instructed. All right, that is all for work problems. We did lots and lots of examples, so hopefully when you see problems like this, you remember to set up your table, and then you will be able to solve the problem.